Hi everyone, it's time for lesson 3. So today you will need the note sheet and the worksheet titled Binomial Radical Expressions. And you will also need the power sheet that I gave you last time and your calculator. So let's get right to it. So in the other lesson we did multiplication and division of radicals. That was the first lesson we did. So today we're going to look at how you add and subtract radicals. So let's go right to it. If you look at number 1, we have the square root of 63 plus the square root of 28. Okay, so if this had been either multiplication or division, you would be able to work on the numbers inside because both of these are square roots. But because this is addition, you cannot just add the 63 and 28 together. That's not allowed. So what you have to do is simplify each radical individually and then later add them. So before you can add, the numbers inside of the radical have to be the same. So let's work on this. So for 63, you would have to look at the perfect squares, which would be the first column of the power sheet that I gave you. And you would look for perfect squares that go into 63. So you would get 9 times 7 is 63. And you would do the same thing for 28. The perfect square that divides into 28 is 4, 7 times. And then from there you would simplify the perfect square. So the square root of 9 would be 3, so that would be 3 square root of 7. And over here the 4 is perfect, so that would be 2 square root of 7. So now that they are both square root of 7, you are allowed to add them together. So 3 square root 7 plus 2 square root 7 would be 5 square root 7. So the answer for number 1 is simply 5 square root of 7. Remember, you can pause and catch up if you need to. So number 2 is similar, but it's subtraction. So we have the square root of 150 minus the square root of 24. You cannot subtract the numbers inside of the radical. They have to be exactly the same number before you can combine them. So we have to simplify each one individually and then later combine if we can. So we want to think which perfect square goes into 150, and you would find that to be 25 times 6. And then you would find a perfect square that divides into 24, so that would be 4 times 6. And again, you would simplify the ones that are perfect. So the square root of 25 would be 5 square root of 6. Keep the subtraction sign, and then the square root of 4 would be 2 square root of 6. And then now they're both the square root of 6, so you would be able to combine them. So 5 minus 2 would be 3 square root of 6. So that is the answer for number 2. Now number 3, the same thing will be true here, but these are cube roots rather than square roots. So you are not allowed to add the numbers together inside the radical. Instead, you have to simplify each one individually and then maybe add later. So you'd want to look at the perfect cubes on the chart that I gave you the other day. So try to find a perfect cube that divides into 135. And you will find that 27 goes into 135 5 times. Then you will do the same thing with 40. Find a perfect cube that divides into 40, and you'll find that to be 8 goes into 40 5 times. So now we'll simplify the ones that are perfect. The cube root of 27 would be 3, so that would be 3 square root 5. Cube root of 5. And over here, the cube root of 8 is perfect. That would be 2, so that'd be 2 cube root of 5. And since they both have cube root of 5, you would be able to combine them. So 3 plus 2 would be 5 cube root 5. So number 3 is finished. Number 4, we have cube root of 250 minus cube root of 54. So you cannot subtract them until they have the same number under the radical. So we have to find a perfect cube that would divide into 250. So you'll find that 125 divides into 250 twice. And for 54, you'll find that 27 divides into 54 twice. And then simplify the ones that are perfect. So the cube root of 125 would be 5, so that one would be 5 cube root of 2. And then the cube root of 27 is perfect, that would be 3 cube root of 2. And since they are both cube root of 2, you are allowed to subtract. So 5 minus 3 would be 2 cube root 2. Number 5 and 6, these are similar ones, but these are fourth powers, or fourth roots, I should say. So on number 5, it's 324 minus fourth root of 2,500. Okay, so you want to look at your power sheet that I gave you the other day. Look at the last column, the fourth powers, and see which one of them divides into 324. So you will find that 81 goes into 324 4 times. And for the second one, you'll find that 625 goes into 2,500, also 4 times. Okay, then go back and fill in the ones that are perfect. So the fourth root of 81 would be 3, so that would be 3 fourth root of 4. And for the second one, the fourth root of 625 is 5 fourth root of 4. And since they are both the fourth root of 4, you can subtract. So it's 3 minus 5 would be negative 2 fourth root 4. So one more in that section, number 6. We have cube root of 192 minus, or no, I'm sorry, plus cube root of 24. So these are cube roots, so you're looking for perfect cubes that divide into these numbers. So 192 has 64. That divides into it 3 times. And 24 has 8, which divides into it 3 times. And then the cube root of 64 is perfect. That would be 4. So that one is 4 cube root of 3. And then the cube root of 8 is perfect. That's 2. So that's 2 cube root of 3. And since they're both cube root of 3, you would add 4 plus 2. So that would be 6 cube root of 3. Okay, so those are the addition and subtraction ones. So now we're going to go next to multiplication and division. So in number 7, we are trying to multiply 6 plus 4 square root 7 times 3 minus 2 square root 7. Okay, so because this is something with 2 terms multiplied by another 2 terms, you can do the FOIL method that you learned in Algebra 1. So first, outside, inside, last. So if you were to do the first, that would be 6 times 3, that's 18. If you were to do the outside, you would multiply the 6 with the negative 2, so that would be negative 12, but you would keep the square root of 7 the same. On the inside, when you multiply 4 square root of 7 by 3, you would multiply 4 times 3, so that would be 12, and then you would keep the square root of 7 the same. Now when you do the last part, 4 square root of 7 times negative 2 square root of 7, you would multiply the 4 with the negative 2, so that would be negative 8. And then this time you will need to multiply the radicals. So 7 times 7 would be 49. Okay, then you're going to go back through and simplify what you can. So there's a couple of things that can happen. Notice in the middle that one is negative 12 square root 7 and the other one is positive 12 square root 7. Those will cancel out. The other thing is at the very end, 49 is a perfect square. It's 7. So really it's negative 8 times 7 at the end, and negative 8 times 7 is negative 56. So what you have left at the beginning is the 18, and at the end is negative 56. So you would figure out what 18 minus 56 is, and that would be your answer. So if you work that out, it would be negative 38. Remember, always pause and restart if you need to catch up. Okay, so number 8, we have 5 minus square root 3, and then 5 plus square root 3. So this is, again, another time to do FOIL. So first would be 5 times 5, 25. When you do the outside, you would just put 5 square root of 3. When you do the inside, you would put negative 5 square root 3. And when you do the last part, it would be negative square root and multiply 3 times 3 and get 9. So again, a couple things can happen to simplify. The 5 square root 3 and the negative 5 square root 3, they cancel out. The square root of 9 is perfect, so that would be 3. But there's a subtraction sign here, so think of that as negative 3. So the 25 that's at the beginning can combine with the negative 3 at the end. So really it's 25 minus 3. So that would be 22. Okay, so number 9, we have 2 plus the square root of 5 squared. Okay, so in math, whenever you see something squared, it doesn't matter what it is, it means to think of it as multiplication times itself. So it's going to be 2 plus square root 5 times 2 plus square root 5. The same thing, multiply together twice. So then you would use the FOIL method to calculate this. So first would be 2 times 2, that would be 4. The outside would be 2 square root 5. The inside would also be 2 square root 5. And then when you multiply the last part, you multiply 5 times 5 and get 25. Okay, this time the 2 in the middle do not cancel. They're both positive 2 square root of 5. So if you were to add them, you would get 4 square root of 5. Then at the very end, the square root of 25 is perfect, so that would be 5. So we've got the 4 at the beginning and the 5 at the end. So if we added those together, 4 plus 5 would be 9. So it's going to be 9 plus 4 square root of 5. So the next one, number 10, is 6 minus the square root of 3. No, sorry, square root of 6 minus square root of 3 squared. So again, seeing something squared means that you multiply it by itself. So think of it as the square root of 6 minus the square root of 3 times the exact same thing again. Multiply by itself. So when you multiply the first, you would multiply 6 times 6, that would be 36. When you do the outside, you multiply 6 times 3, so that would be negative square root of 18. Same thing would happen in the middle, you would get negative square root of 18. And when you do the last part, you would get positive square root of 9. Okay, so in the middle, the negative square root of 18 and the negative square root of 18, that would combine to make 2 square root of 18. I should say negative 2 square root of 18. Then at the beginning, we have the square root of 36, that would be 6. And then the square root of 9 would be 3. So you have the 6 at the beginning and the 3 at the end. 6 plus 3 is 9. So you've got 9 minus 2 square root of 18. Now this one is not quite simplified because of the 18. In order for it to be simplified, you have to think, are there any perfect squares that divide into 18? So yes, there are. 9 goes into 18 2 times. So if you simplified the 9, that would be 3 square root of 2. That takes care of the 18. Now there was a 2 here before, and then you've got this 3 square root of 2. So what you would have to do is multiply the 2 times the 3. So when you write your final answer, the 9 comes down and the subtraction symbol, but 2 times 3 would be 6 square root of 2. So then that would be your answer for number 10. Pause and restart if you need to. Okay, so number 11, 3 square root of 10 plus square root of 2 squared. So that means you're going to multiply it by itself. So it will be 3 square root of 10 plus square root of 2 multiplied by 3 square root of 10 plus square root of 2. And again, do FOIL. So for the first part, you'll have to multiply 3 by 3. That would be 9. And then you also multiply 10 times 10. So that would be 100. When you do the outside, you'll keep the 3 on the outside, but you'll multiply 10 times 2, and that will be 20. Then when you do the inside, keep the 3 there, but multiply 2 times 10, so also 20. And when you do the last part, 2 times 2 would be 4. So we'll have to do several more things before we'll have our answer. So one thing is we could add 3 square root 20 and 3 square root of 20. That would be 6 square root of 20. At the very beginning, you've got the square root of 100, so that would be 10. So this is really 9 times 10, which would be 90. And then you also have at the end the square root of 4, which is 2. So you've got the 90 at the beginning and the 2 at the end. Together that would make 92. So you've got 92 plus 6 square root 20. Now this is not quite simplified yet because you can simplify the 20 further. So you would want to think what perfect square goes into 20. So it turns out that 4 goes into 20 5 times. So the 4 would simplify to 2, so that would be 2 square root of 5. But then there was the 6 there originally, so the 6 is going to have to be multiplied by that 2. So the 92 would still be there, but then you would have to do 6 times 2 is 12, square root of 5. 92 plus 12 square root of 5. Okay, so that one is a little more complicated, so please stop it and catch up if you didn't quite get all that. 92 plus 12 square root of 5. Okay, so that takes care of multiplication. So then you will see there are a couple of division problems. So that will be the next thing, and then we'll be done. So 2 more problems. So we've got 5 plus square root of 3 over 2 plus square root of 3. Okay, so earlier in the year, we learned that a fraction is not considered simplified if it has a radical in the denominator. So you have to do something called rationalizing. So the way it works with this case, when you have plus or minus with the radical in the denominator, you have to use what is called its conjugate. So the conjugate means that you keep everything the same except for the sign in the middle becomes the opposite of what it is now. So rather than 2 plus square root 3, it will be 2 minus square root 3. The only thing I changed was the sign in between the 2 radicals. Okay, so what you're going to do is multiply, that's a multiply sign, the numerator and denominator by that same thing. So whatever you do on the top, do to the bottom as well. That is called multiplying by the conjugate. Okay, so once it's set up like this, we're going to do FOIL. So you're going to think, what are these 2 things multiplied together using the FOIL method? So first would be 5 times 2, that's 10. Outside would be negative 5 square root of 3. Inside would be positive 2 square root of 3. And then last would be negative square root of 9. And I'll simplify that in a minute once I get the denominator done. You're going to do the same thing in the denominator. You're going to FOIL this and FOIL this together. So first would be 4. The outside would be negative 2 square root of 3. The inside would be positive 2 square root of 3. And the last would be negative square root of 9. Okay, so that's what it would look like after it's been FOILed. So from there, we're just going to simplify things up a bit. So we've got this 10 at the beginning, And at the end, we've got negative square root of 9. So you can think of that as negative 3. So the 10 at the beginning can be combined with that negative 3 to make 7. Then you would be able to add the middle radicals because they're both the square root of 3. So negative 5 plus 2 would be negative 3 square root of 3. So we've got 7 minus 3 square root of 3 in the numerator. So now the denominator. So remember at the end, this negative square root of 9 would be negative 3. So the 4 at the beginning could be combined with the negative 3 at the end. So that would be 1. Then the 2 in the middle could be combined. So negative 2 square root of 3 and positive 2 square root of 3, that cancels out. So you're just left with 1. Now a fraction is not simplified if it has 1 in the denominator, so you can just write your answer without the 1. So you can just say your answer is 7 minus 3 square root 3. So number 12 is now done. Pause and restart if you need to catch up. And we just have one last problem. 13. Okay. So we've got 3 plus the square root of 5 over 4 minus the square root of 5. Okay, so the rule is that you cannot leave a radical in the denominator of a fraction. It's not considered simplified. So we're going to get rid of it by multiplying by its conjugate. So you're going to multiply the numerator and denominator by the same thing. So the only thing you change is the number between the two numbers. So that minus sign is now going to be plus. So it's going to be 4 plus the square root of 5. And you're going to multiply both the numerator and denominator by that same thing. What you multiply to the bottom, multiply exact same thing to the top. And then we will FOIL straight across. So like this will be FOILed with this. So first would be 3 times 4, 12. The outside would be 3 square root of 5. The inside would be 4 square root of 5. And the last would be square root 25. Same thing on the bottom. We're going to FOIL this and FOIL this. So first would be 4 times 4, 16. The outside would be 4 square root 5. The inside would be negative 4 square root 5. And the last would be square root 25, minus square root 25. Okay, now we can simplify this. So the square root of 25, since it's positive, will be positive 5. So the 12 at the beginning could be added with that 5. So 12 plus 5 would be 17. Then these two radicals in the middle could be added. So 3 square root of 5 plus 4 square root of 5 would be 7 square root of 5. Now in the denominator, at the very end, we've got negative square root 25. So that's the same thing as negative 5. So the 16 at the beginning could be combined with this negative 5 to make 11. And then in the middle, the 4 square root 5 and negative 4 square root of 5 cancels out. So those would be gone. So your answer is this, 17 plus 7 square root of 5 all over 11. Make sure the 11 is over both of those. All right, so that's it. Pause and catch up if you need to. Okay, so lesson 3 is over. Hope you all are doing well. I miss you. Talk to you later. Bye-bye.